The next thing I want to talk about are some considerations as to why we would want to save things into a geodatabase and as to why we would really need to format our data. So the first major consideration is to centralize our data. We can centralize our data using a geodatabase, and by doing this it makes it fairly easy for us to share our data, so we don't have to go onto our hard drive and click those 6 to 8 separate files that consist of a data set. Instead, we can just share that geodatabase container that has all of those individual files stored inside of it. And we don't have to worry about making sure that all of it made it over, because we know that it's all centralized and stored into that geodatabase. The second major consideration is processing efficiency. So to avoid unnecessary geoprocessing, what we typically do is clip our data down to a manageable size. So if you recall our Marlet Park example, it's actually a fairly small site compared to the actual overall size of the data set that we are working with. It's probably a fraction of the entire Riley County data set. So we don't want to do geoprocessing on the entire data set, but just for that small area that we are interested in. The next major consideration is consistent spatial projection. So all of our data sets right now are in a wide variety of spatial projections. So we're going to want to reproject all data to a common spatial projection so data will line up in the XY direction. So this often means choosing between a spherical or cylindrical / planar projections. If you recall, in a previous tutorial I talked about the differences between geographic and projected spatial projections. The next major consideration is our unit measurement consistency. So oftentimes this means choosing between meters and feet. And regardless of what we choose, we need to make sure that our Z information also matches up with our XY information as well. And finally, we have Mosaic. Oftentimes our data set will come in tiles, so we don't want to geoprocess on each and every single tile. That task can become very, very repetitious for us. So Mosaic allows us to kind of merge together separate tiled data sets together as one to prevent repetitious operations. So thus far you've heard me mention the word geodatabase quite often. And a geodatabase is a geospatial data storage framework for ArcGIS designed to centralize spatial data and its management. It's often used iconically as a series of disks that are kind of stacked on top of each other, as the image to our left kind of illustrates. ArcGIS 10.x, so version 10 on forward, prefers all of its data to be placed into a geodatabase. If you're working on a geoprocessing task and it keeps failing when you know it should work, one thing that you could check for is to make sure that the data that you're trying to geoprocess, its source data and its destination, where you're going to save the results, is indeed in a geodatabase. Sometimes the terminology of your data set may change once it goes into the geodatabase, making it kind of confusing, especially if you are new to ArcGIS. Rasters will remain termed raster. Sometimes they're called surfaces, depending upon the type of raster that you are working with. But shapefiles, their term tends to change to feature class. So sometimes you'll hear the term feature class, and it's basically means shapefile, but they just call it feature class once it enters into a geodatabase.